Welcome to our channel, Moto Mouths Uganda, where we talk about everything to do with cars, what happens inside your car, outside your car, on the road, off-road, everywhere. We shall be talking about that. We have someone who is very passionate about cars, Engineer Ivan Chibuka, who is going to take us through certain aspects of the car that we may not know about or that we think we know, but we need better explanations from the people who understand these things better than us. Welcome, Ivan.
Thank you very much, Alan Senyonga, my old boy from our days in Muiri, Soga College Muiri. Thank you very much. I'm glad to be here today to participate in this discussion.
Yes.
Thank you.
I want you to tell us about systems, automotive systems, because most of us just buy these cars, and that's the end. We just know the brand, sometimes the sound of the engine, and we are satisfied. We don't know. We only ask engine in Namu, and that is it.
or whether it is the radiator is leaking water.
Yes. Sometimes even when it is leaking, we don't know where the water is coming from. You find someone is parked on the road, is saying, oil aika, but they don't know what is happening. So please give us a bit, of course, we are not engineers, but we believe you can bring it to our level.
Okay.
Yes.
Let me try. First, once again, my name is Ivan Chibuka. I'm an environmental engineer by profession, although I do so many other things to survive. One of them in the past, for the last about 12 years, I've been involved in vehicle repair. It's not my primary preoccupation, but sometimes I get involved, especially surprisingly, with complicated cases that even experienced mechanics have failed to resolve. So today, in future, we are going to be discussing many aspects of vehicle technology, but today I wanted to begin with the basic part of a vehicle, or most vehicles, is the engine. No engine, no car. Even if you have the best sound system in the vehicle, but the engine is not running, what you have is basically a radio on wheels. But so without an engine, you don't have a vehicle. Let me share a small presentation that I have on this topic. Yeah. I don't know if you can see my presentation.
Yes, I can see it.
Yes,
Engine operator.
Yes. So essentially, there are many variants of internal combustion engines. Internal combustion means basically it means a fire that happens inside the confined space. So in the case of engines, the typical engines that you are used to, whether it is a train, whether it is on a boat, whether it is on a car or a lorry, typically the combustion happens inside where you cannot see it. That's why they call them internal combustion engines. It's not like an open flame that you can see. These fires or small explosions happen very quickly, and they are controlled and timed very well to get the power that you need to move your vehicle and to do other things. Because the engine these days, the engine doesn't just move the vehicle. It will run the air conditioning compressor, it will run the alternator to charge the battery. But amongst the many variants, most engines that we are familiar with on the vehicles are the four-stroke type. What does four-stroke mean? you can see an image of an engine. In this case, it's what they call a straight six-cylinder engine from BMW from the early 90s to the early 2000s. Just to acclimatize you or to make you familiar with some of the items you typically see when you open the hood and you're looking at the engine. I'll spend a minute or two here to explain. This is just the plastic cover that is covering the ignition coils. But can you see my cursor moving? When I move my cursor over the image, can you see it?
Yes, I can see it.
Yes. So where my cursor is, that is the intake manifold. Air enters the engine through the air cleaner on this side, goes through that tube. There is this small thing here protruding. That is the mass airflow meter. Many of you may have heard about it. Your mechanic tells you mass airflow, air food day. That is the sensor. It calculates how much this thing here, this one. It calculates how much air is going into the engine, and these calculations are sent to the computer. So the computer now knows exactly how much fuel to send to the cylinders to be able to get the efficient burn. Because with these, especially the petrol engines and diesel engines as well, if you get the mixture wrong, the air fuel mixture wrong, the engine won't run. If you have too little fuel or too much fuel in the mixture, it won't burn. If you have too much fuel, all you may see is just black soot. In fact, on cars, when you see black soot, just know the mixture is too rich. You are using too much fuel for the condition. Now, once the air goes through there, it comes to the manifold. Still, that is a jargon you may have heard from the mechanic, but now I'm trying to teach you so that the mechanic doesn't sound like he's talking Greek when he's talking to you. Of course, there are things you cannot see here, but this, for example, is the hole where you put oil when you are changing the oil or topping it up. And then this, most of you at least can identify this. This is the dipstick for the oil. And then on this side, what you can see here, that is the exhaust manifold. You can see there are 6 pipes here. So that means this is a 6-cylinder. A 4-cylinder would have 4 of these and so on. And like I said, this is a straight 6. And briefly, I will show you what I mean by that when I say straight 6. Oh, I'd forgotten about this. This is what you call the self, the ignition motor. This thing at the bottom, my cursor keeps disappearing. Yeah, where the cursor is right now, that is the ignition motor. So when you turn your key, when you're cranking, this is what turns. It bites into the flywheel and then begins turning this engine. Once the engine is running on its own, this thing stops. That's when you push the key back. That's when you release the key. Then this thing stops working. So in Uganda, we call this serefu. So when mechanics say serefu, this is what they mean. And then there's a fan here. This one looks like it was built to turn with the engine when the engine turned, but increasingly, most of these cooling fans are electronic. So you can have the engine running without the fan running, or you can have the fan running when the engine is stationary, and vice versa. So as we go along in future episodes, you will learn more about this, but let me move on forward now. Now here, remember we talked about 4-stroke cycle. What that means, I mentioned earlier that internal combustion engines have precisely controlled explosions going on. When you hear your engine running, those are thousands of small explosions happening and very well timed to give you power. So let's begin. The whole thing begins with the intake stroke. Remember from the other image, previously you saw the air coming from this side, from the right side, in this case, and this is what they call the intake valve. This is the exhaust valve. I don't know if you can see where my cursor is. This is the ignition spark plug. And then you have the crankshaft here. You are looking at this from the front. It's as if you're looking at a cross-section of one cylinder. The engine may have 6, 4, 8, 10 cylinders, but in this case, we are just looking at the cross-section of one cylinder from the front. Now, this here is what we call the piston. And this entire arrangement where the piston is moving up and down is called the cylinder. So when you go to the garage and you hear the mechanic talking about cylinder, piston, karanka, when they talk about, they use jargon. It may be a bit of vernacular, or pidgin English, but that's what they mean. When they say karankes, they mean this bottom pan here, this like tank where the crankshaft settles, and this is where when you stop the engine, the oil will settle. So let's go back up. Don't want to spend a lot of your time. Oh, what you see on the sides here, those are the paths through which the engine coolant passes to cool the engine. Remember, the explosion is happening mostly here at the top of the cylinder. That is where the fire, the real fire is happening all the time. And when that fire happens, when that explosion happens, it pushes, every time it happens, it pushes the cylinder, the piston down. And then the piston moves down the cylinder. I don't know, Alan, if you are one of those naughty boys in primary school who used to use the big penis. We used to pull that nib and the ink out, and then we got orange peelings and we would push orange. You would use the pen to cut out a small portion of the peeling, and then one portion of the peeling would push the one in front of it, and there would be air in front of it, and then you'd shoot it at a guy in front of you and then hide. Do you remember that?
Yes, I remember.
So this is essentially what is happening here. When the piston is, when the explosion happens, it pushes the piston down. And that force is translated into a rotary motion by the crankshaft. So let's begin with the intake. You see at this is the four-stroke cycle engine. So we have four strokes, sorry. The induction, the compression, the power, and the exhaust. So for each cylinder, this is how things peter out. You begin by the intake valve opening. When it opens, the air is going to rush in. In many cars, but that is now changing, the air rushes in with already mixed with the fuel. There is an fuel injector just before the intake valve that squirts out fuel, which is now pushed into the cylinder. This is the cylinder. This is the top of the cylinder. So that mixture is pushed in when the valve opens, when the intake valve opens, that mixture is pulled in. How is it pulled? Because on the induction stroke, the piston, this thing, is moving down and it is creating vacuum inside the cylinder. So air rushes in to fill that vacuum, and that air comes in with mixed fuel. So it goes to what we call bottom dead center. That is the lowest point for the cylinder. And at that point, when you move on to the second image, part 2, you are seeing now is called the compression stroke. But notice now that the intake valve is closed. You see that the intake valve is closed now. It was open before in the induction stroke. Induction means something was being pulled. The air was being pulled in. So the intake valve was open. But now the intake valve is closed and the exhaust valve on this side is also closed. But the rotation is happening. The crankshaft is pushing the cylinder back up. Remember, we began with, in the induction stroke, the cylinder was moving downwards and it was causing vacuum. Now, with the piston being pushed up while the valves are closed, there is nowhere, there is no escape route for the gas mixture now inside to escape. So compression is going to happen here. Alan, you remember what you are doing when you are going to shoot the guy with the pen and the orange peeling? That pressure
Yes,
you
sir.
apply, that pressure you used to apply with the nib of the pen is what is happening now in the cylinder. But that pressure is being applied by the piston through the crankshaft. So that air fuel mixture is trapped inside there until the piston comes to the top, the topmost position, the farthest it can go up. And this is now called top dead center in mechanic speak. So when you hear your mechanic talking about top dead center, that's what they mean. So now on the power stroke, there is nowhere else now for the piston to go except down. But now at the end of the compression stroke, which also marks now the beginning of the power stroke, that is when the computer commands the spark plug to fire. Remember, you have a mixture of air and fuel, and it is closed and it is compressed. It is already pressed very hard. In fact, it has already started warming up. So usually it is even very hot. That's how diesel engines work. Diesel engines, by the way, don't have these ignition plugs. The ignition happens by itself, but just when you press the fuel and air together, that's the difference between the diesel engine and the petrol engine. I'll come back to that later. But in a typical petrol engine, the spark will happen and then the explosion will happen, and that explosion is now going to push the piston down the cylinder now a second time. We are still in the same cycle, but now we are in the third phase of it. This is the power stroke. This is when you hear the engine firing, the cylinder firing, creating power. And it goes down with such force that it drives all the other. At that point, the cylinders don't fire at the same time. They fire in sequence. So if you have 4 cylinders, there's always one cylinder firing, another is on exhaust stroke, another is on compression stroke, and so on. And the cylinders which are not on power stroke are being driven by the crankshaft because there is another cylinder at that time which is on the power stroke. I don't know if I'm getting too technical, but I'm trying to sound simple. I don't know if it is making sense to you, Alan. If you are challenged, you let me know, and I will elaborate more on it. But basically, the explosion now happens, but you can see the valves are still closed, both the exhaust and intake. So everything, the explosion is contained in the cylinder, but the only route now for the gases to expand is to push the piston down, and that happens, and that's what gives you propulsion. This eventually ends up at your wheels, and it gets you moving. And then finally, when this piston reaches bottom dead center, the second time now in the same cycle, but this is the end of the third stroke, the power stroke, you now have the exhaust stroke commencing. If you look carefully now at the valves, the intake valve is still closed, but the exhaust valve now opens while the piston is moving up and is expelling the exhaust gases now because there is no need for them anymore in the cylinder. Although for cars with the turbo systems and the cars with EGR systems, that some of that smoke or exhaust gas is sent to those systems. Usually the turbo is powered by exhaust gases coming out of the cylinder. If you are satisfied with that description that I've tried to make simple, we can move forward.
Yes, I think we can move forward.
Yeah, if you have any questions, you can raise them. Yeah. I realize that I cannot explain everything, and it may not be easy to understand everything the first time. I advise our viewers, because this is recorded, they can go back and review. If this interests them, they can go back and review what I've said. But essentially, the exhaust stroke is the end. At the end of the exhaust stroke is the end of the cycle. And then the cycle repeats again. The intake valve opens again, the piston goes down again, and the whole cycle repeats many, many, many times until you switch off the engine. But like I said, this happens in sequence. If you have a one-cylinder engine, like on the grass mowers, you have you have this cycle happening once, one rotation every so many. But if you have 4 cylinders, like on most small cars, the Toyota Corollas and all that, most engines below 2.5 liters, they have 4 cylinders. There are some cars with 3 cylinders. Those typically have engine size of 900 cc or 1000 cc. The Pasos, some VTs, those small cars. 4-cylinder usually begins from around 1.2 to 2.4 liter engines, and generally, and then above 2.5, generally you have more cylinders. Some vehicles even have 5 cylinders, notably Volvo has such. And then some cars have 6 cylinders. Some of them are straight 6. Some of them are V6. And that brings me to discussing the cylinder layouts. Inline or straight. These cylinders are in a straight line, like the one we saw for the BMW earlier. They can be vertical, inclined, or horizontal. Usually, they are vertical. The majority, at least the majority of the ones I've seen in the garage, straight cylinders, inline, usually they are vertical. You can find these in the BMW I just mentioned, a lot of the 4-cylinder cars that you have in your garage, and that is for the inline 4-cylinder. Inline 6, you find a lot of these in the BMW I just showed you, in the Toyota Mark II, up to the Grand, I think, the Toyota Brevis. Those 6 cylinders are usually straight in line. And generally, some manufacturers don't do the V, which is my next discussion, the V cylinders. BMW, for example, I've not seen a V6 cylinder in a BMW. No, I've not seen one. I don't remember one. They are usually straight, but some manufacturers have a combination of V and straight. They usually do straight cylinders up to 4 cylinders. Above 4 cylinders, like the Mark X, for example, it will also have a 2.5 liter engine similar to the Mark II, but the Mark II engine is straight 6. The Mark X has a V6 cylinder. The cylinders are set at a V. There is an angle between them, between 3 sets of cylinders. They will organize them that cylinder 1, 3, and 5, the odd ones, are lying in a certain way, and then you have 2, 4, and 6, like that, crossing them. That's what that's how the V is made, and they call them V6 or V8. They are arranged in that order. Straight are like this, in a line, going backwards. V are like this. You have 1 lying in this direction, 2 like this, 3 in this one, 4 like this, 5 in this one, and so on. You can even have V10 and V12 in the Ferraris and the Maseratis. And then there are opposed cylinders. These are usually straight and opposing each other. You have 2 lying in a horizontal position like this, and 2 like this, or 3 and 3, or 4 and 4. The most common variant is Subaru engines. Most 4-cylinder Subaru engines are like this. The cylinders are horizontal. I don't know if that is what makes them sound like they do, because they are kind of unique. but you have two cylinders facing this way and two like this. They call them boxer engines because the whole arrangement, the whole engine, when you get it out, it looks like a box. It's not vertical, so much vertical like the other inline straight and V type. Yeah, so those are the opposed ones. I don't know many manufacturers that do it. They are, it's mostly Subaru. Yeah, in fact, they even have those boxer engines, even in diesel, they have them like that. If you can get access to mid 2000 onwards diesel Subarus from Europe, you find they are still in that arrangement. It's unique to Subaru, kind of. And then engine firing order is important, like I mentioned. This happens in a sequence. I've tried to describe it in simplistic terms, but everything is timed critically. That's when you hear your mechanic saying, kola timing, mpa sente, nsibe engine, njitaiminge. Oba engine yayononese, yachamuse, tulina okuddamu ne tugitayiminga. Means they have to undo components of the engine that are timed, repair them, and when they are putting them back together, they have to time the engine. And most time, this is what creates a lot of the workload when you do engine overhauls, the timing part of it. Yeah, and again, this is my last slide where I discuss the importance of timing. This is an example of timing the previous engine that I showed you. The mechanic will be looking at marks. There are pulleys inside that engine, which you don't normally see, but when they open up the engine, you will see those things. And then there is a chain or a belt that runs around. But before it is placed on, these pulleys have to be put in a specific position. If you don't put these pulleys in a specific position that the manufacturer said they should be, you are now going to have those valves. You remember here, do you see that there is a danger of when the valve opened, like in this case, and there is a piston coming to the top, that the valve can knock the cylinder and destroy the engine even more. So timing is very, very critical. It's a science, actually. If it dependent on the manufacturer, the way they decide to time the engine, there is no alternative for that. When you are putting that engine back together, you have to follow their specific instructions. That's why you find mechanics that specialize in engine rebuild. That's what they are doing. Please respect their art. I know when you see them with the greasy overalls and all that, you guys, by the way, most car owners, you don't really like paying those guys well. They they really do technical stuff with your car. So thank you. I think I've rambled on long enough about this. I hope our viewers are going to have something to learn. But they can get back to in the comments. They can ask specific questions about things they don't understand. If I realize it wasn't many people didn't get it very well, maybe in the future, if the viewers are interested, I can come back and explain it better. Thank you very much, Alan. That's what I had today. I don't know if you have any questions regarding that for the benefit of our viewers.
Thank you very much. The things you have mentioned are certainly a bit technical, and a lot of them may just fly through my head. But the bit that I've liked, where you keep mentioning some of the terminologies we hear when we go to the garage, that helps me not to connect what you are saying with what I have heard, because always those people say things and sometimes we don't know what they're talking about. But now when we get some sort of a sneak peek inside the engine and how it works, things are starting to make sense. Like I have seen the fan belt, it's called the fan belt. Then now when I see the pulleys, I can start to see why things be moving when they're repairing, and then they say, you first start the engine and we see. So thank
Yeah. So
for
when they say,
that.
for example, Tiebuse timing, that means things have gone now out of timing, and you further, if the engine is not yet damaged, further damage can happen if you continue running the engine. So when they say Ebuse timing, usually that's not a good sign. It is sometimes it is recoverable from if there is no internal damage that has happened yet, but usually it means a timing job is coming up. Just be ready. Yes,
Okay.
and the engine sovereign okubuka timing for so many reasons. We shall not go into that for now. I just wanted to give you an idea of how an engine operates, how you get the power out of the engine, what the fuel you are burning that is costing you so much money at the pumps. How is it being mixed with the air? In future, we shall have further other discussions about engines and many things about cars, but with this one, let me end it here.
All right. Thank you so much. If I don't know if briefly you can tell us something about this mistrust that we have with the mechanics and people running garages. Now that we are talking about how these cars work internally, there is that mistrust that we have with the mechanics. Sometimes we only go for the one who has been recommended by someone who has been driving for a longer time. Other times we send there the man because we think if the woman goes, she'll be cheated. You know, all those scenarios occurring. Why is there this mistrust with the garage operators?
Yes, if we, for example, use the example today I've discussed about the engine, a lot of people, you have an engine in the vehicle, you like how it sounds, you want an engine that is relatively new, that has not seen so many kilometers because it is better. You want a bigger engine most times. Some of you have small engines, but you want to get a lot of power out of them. And many of you have been cheated, by the way. Put this additive, put that, have this tune, try to get more power out of the car. It is because a lot of you, the vehicle owners, I don't want to blame the mechanics, because sometimes the mechanics just want to please you. You give them a challenge and they try to, they don't want to deny taking your money. They'll try to take the money and then try to please you. But in reality, it is because many of the car owners are ill-informed. I don't want to say they are misinformed. I want to say they are ill-informed. You don't have good information regarding what is possible and what isn't. And this is one of the reasons why I am trying to explain things like this in simple terms. So the mistrust is going to develop when you try to request for something that the mechanic cannot actually deliver. Sometimes either because they don't know or because they know, but they don't want to argue with you. We have this saying in Kampala, bakukubanga bozze. So if you come, you are very hot, you had somewhere that you can change a 1 liter engine in a V6 to perform like the V6 in a BMW, and you want to do certain things to the engine, the guy may decide not to argue with you. He will take your money and claim there are things he's going to do. And then he will say he put them, but that is as much performance you could get out of the engine as possible. So the mistrust in this case, there are so many reasons for the mistrust, but I'll point out that many times it is because we, the owners of the vehicles, neglect to learn some basic things about our vehicles. That gives the opportunity for cheats among the mechanics. Not all mechanics are cheats, but some are. And some don't cheat because it is intentional. They cheat because you are arguing with them. They try to advise you, you have a big head, they want your money. Bakukubanga boze, bottom line. There are other reasons for mistrust developing between car owners and the mechanics and the garages. I'll touch those on another time. But the number one reason, I think, we, the vehicle owners, try to learn as much as possible about your car. Don't leave everything to anybody on the street or anybody in the garage to explain to you. Some of those, I'm sorry to say, some of the mechanics are quite illiterate about what they are doing. Unfortunately, I'm sorry to say that. Just because he is wearing overalls and he's very smart, he has a good tongue, talks those things of Kalankesi, what. You say this is a mechanic. And he tells you things which would ring bells, but you don't, because you don't know anything, you miss them. And then they are good guys. Some of them, they are very humble. They let you pass. You pass by them, you don't believe in them, you pass by them, you go to the guys with a good tongue, and you get beaten.
Okay, thank you so much. My biggest takeaway is that we should not go to the garage when we are also very ignorant about the cars that we own or the ones that we are driving. We should make an to learn a few basics, or to listen as opposed to arguing, to listen to what the mechanic is trying to explain. And then we as you suggested.
Yeah, I'll be giving you tips in future on how to avoid getting beaten and how to develop a judgment for the competence of a garage or mechanic. For example, if you walk, let me say this last one in the last few seconds we have. If you walk into a workshop that appears to be very busy, they are fixing cars, everybody is busy, and there are many cars parked. Almost the thing looks like a bonded warehouse. Just no, these are gamblers. A good garage, cars should be coming and leaving. If you see people are busy, but there are few cars left inside the garage, usually that's a good sign that those guys know what they are doing. That's one tip I will give you for today.
Thank you so much for that tip. We shall see how to start applying these tips and probably get a better experience with our cars and with the whole experience on and off the road. Thank you very much, Engineer Chibuka.
You're welcome. You're welcome, Alan. Thank you very much.